let's look at in more detail the step-by-step of Jenkins by referring to this flowchart. Okay, first we plot the time series plot of the data. Okay, this is where we can interpret the component of the data, whether it has trend, seasonality, and so on. So that is just our own interpretation or initial assumption. Okay, then we know that for time series plot, we only based on the personal interpretation. So we need to look or test into more detail. So first we test whether the variance is stable or constant. So this can be carried out by compute the Box-Cox transformation. Okay, so from the Box-Cox transformation, we will estimate the lambda value. So the lambda, if it is equal to 1, we don't need to transform the data. And then also if the estimated lambda equal the value of 1 in the lower or upper bound, okay, in between the lower and upper bound, if it include the value of 1, we do not need to transform the data. So if not, we will transform the data based on the value of lambda. So there are several types of transformation where we have learned in the beginning or in the chapter, okay, the previous chapter. So that is where we can apply the transformation. So after that, we check the ACF and PACF plot, whether the mean is stationary or not. So this one also we have learned before. Okay, so you need to follow the flowchart. Okay, first the variance, because if, okay, afterwards I explain. And then we check the mean. Okay, so from the ACF and PACF, we can define whether the mean is constant or stationary. Okay, so if the mean is not stationary, we will apply the differencing. So we have learned the differencing before. Okay, so okay, this one for the variance. Okay, let's say the variance is not constant. Okay, let's say it is increasing like this. Okay, increasing. So when we apply transformation, for example, ln, okay, so then the variance will become constant. Okay, and then for the mean, let's say it has trend. Okay, so if we take the differencing for the data that has trend, so the data will become like this. Okay, it will be more stable or stationary, because we can see that if the data has trend, of course the mean is not stationary, because the mean depend on the time, and for example it has increasing trend, so the mean also will increasing. Okay, so if we take the differencing, it will become constant. Okay, so we have to follow the flowchart here, the variance first, which is we will apply the transformation first, and then we check the stationarity in terms of mean. Okay, that is why because if we start with differencing first, the data will might have negative value. So if the data contain the negative value, the Box-Cox transformation cannot be computed. That's why we need to apply transformation first and then differencing. Okay, next, after we have make the data stationary in terms of variance and mean, we move to the next step, which is the model selection. So from the PACF and PACF, so this one based on ACF and PACF. So from the video previous weeks, we already know that the order of P and Q we can define by using ACF and PACF plot. So from that we identify the value, the model or the order of P and Q. So after that, we will estimate the parameter. And then we check whether the residual is correlated or uncorrelated. If the residual still correlated, we need to modify the model. So maybe, okay, this when the residual is correlated, indicate that the model, which is the model that we estimate here, is not sufficient to capture all the information in the data. That's why the residual still correlated. So we need to modify the model and then we check back the residual. So this is the iterative step. Okay, so until we get the residual is uncorrelated, so we move to the next step, which is we check the parameter significance. Actually from here, okay, when we estimate the parameter, also we have to check whether the parameter is significant. Otherwise, so let's say some of them are not significant, so we need to drop or exclude the parameter. Okay, so if the parameter also all significant, then we can proceed with the last step, which is the forecasting. Otherwise, we have to modify back the model. Okay, so this one, it should be the parameter is significant, not uncorrelated, because uncorrelated referring to the residual, not the parameter. This is the general guideline where we can identify the model Box-Jenkins by using the ACF and PACF plot. Okay, if the ACF so we need to refer to both plot, then we propose the tentative model. Okay, first, if the ACF is decay to 0 with exponential pattern, and then the PACF is cut off at lag P, so this will indicate that the model should be or might be AR order P. So here cut at lag P, so the order is is P. For example, the PACF is cut off at 2, so the order of AR is 2. So you can try this AR2, so see whether the parameter is significant and also the residual is uncorrelated. Otherwise, we have to try other model. So if it is like this, so means that the cutoff is at ACF and also the PACF is decay exponential pattern, it will become the MA order Q. So this one is lag Q, so this is the order of MA. If both of ACF and PACF is decay to 0 with exponential pattern, so we can try the ARMA, where this is the combination of AR and MA model. Lastly, if both are cut off, so we can try whether it is ARP or MAQ. Okay, so basically this is just a guideline. So the ACF and PACF plot quite difficult actually to interpret. So this is just a basic guideline. So we need to try several models actually in order to find the best model of Box-Jenkins. Okay, so for today's class, please log in or answer the Google form here in this link. Okay, so as the evidence of attendance for today's class. Okay, you can try the Box-Jenkins for your data for the project. Okay, maybe after this I will show you how to analyze data using Box-Jenkins by using Minitab, inshallah. Okay then, bye. Assalamualaikum.